Alright students, welcome to the next lesson of our networks unit. This is on chapter 9D, planar graphs. Previous lesson we looked at chapter 9C, which were isomorphic graphs, connected vertices in graphs, and adjacency matrices. So go ahead and watch that lesson before you complete and watch this lesson, please. Alright, chapter 9D, we're looking at what we call planar graphs. A planar graph is a graph that can be drawn on a surface without any intersecting edges. So the key word here, or the key thing to look for, is without any intersecting edges. Now you'll notice that when I did some examples in the previous lessons, some graphs are considered planar, like this graph, okay, and some graphs aren't, like this graph, okay. So the criteria for a graph to be planar is none of the edges are allowed to cross one another. Okay, that is a planar graph. So determine which of these graphs are planar. Okay, so sometimes what you'll find is with questions like these is it can be easy to figure out whether a graph is planar. So if you look at this graph here, this is planar. Straight up, because you can see that none of the lines intersect at all, or none of the edges intersect. Okay, what about this graph here? Is this planar? Well, clearly you can see some of the lines are intersecting. So like, for example, this edge to that vertex there, that intersects with this edge there, with that edge, and this edge. They're all intersecting one another. Okay, so this is not planar. Plain and simple. However, this one here you can see, okay, is this graph planar? Okay, well, sometimes some graphs can be easily identified as planar, and sometimes they can't. So at first glance you might think that this graph isn't planar, okay, but actually it is planar. However, the only way it can be planar is if we actually redraw the graph. So sometimes you'll get questions where you're asked to redraw a graph so it is planar. Remember, meaning none of the edges intersect one another. So how can this graph be planar? Well, let's redraw it so that the lines or the edges do not intersect. So I'm going to start off by drawing these connections here between these vertices. You've got that, you've got this, and then this is connected to that. Notice how I haven't drawn these ones here and this one yet, okay? Because I will make this somehow planar by redrawing it. So you can see that this vertex is connected to this vertex twice. So let's draw two connections to that, making it planar. And notice how I actually go around, okay, to make those connections. Okay, and the last one is this big loopy one here. And now you can see that the graph is planar, okay, because none of the edges intersect with one another, okay. So this graph is actually planar if it's redrawn, but in essence it is planar, but you have to figure out whether it is planar or not by redrawing it. Okay, so this graph there is planar. Some graphs are way too complicated for it to become not a planar graph. This one here, you actually cannot redraw, okay, in a way, okay, where you maintain the same connections, okay. As much as you try, it's impossible. Okay, so some graphs are simply not planar, but some you can make. All right. Planar graphs, vertices, edges, faces. Okay, so if a graph is planar, okay, and drawn so that the edges do not intersect, its edges will divide the surface into non-overlapping regions called faces. So basically, when you get a planar graph, what happens is the lines create faces on the graph. Okay, so one thing to remember, and a lot of people forget this, is that the outside of a graph the region not completely enclosed by edges is considered to be a face. Okay, so the area outside of the graph is also a face. So let's look at this one here. This one's easy. Okay, this graph has got 1, 2, 3, okay, faces. Okay, let's write that down here. 3, because remember the planar, the nature of it being planar, meaning none of the lines intersect, make a face on the graph, and also the outside of the graph is considered a face as well. All right, so that graph has 3 faces. Let's look at this one. Okay, this graph here, we might need to redraw to make it planar, okay? Because I can see that 2, or actually it will be 4 of the edges intersect with one another. So I'm going to redraw it. If you, what I ask you guys to do is practice redrawing your graphs to make them planar. If you want, pause the video and try and make this a planar graph. Otherwise, feel free to watch me make it planar. So I'm going to draw my connections. I've got this. Actually, let's make it neater. There, got that. I'm also connected to this, and that's connected to that vertex, and there. And you've also got these connections. Okay. So notice what I'm actually skipping or not drawing are the edges that I know I can move around. So I can see that this vertex is connected to that vertex there via this line or this edge. I just haven't drawn it. So I'm just going to draw it out here. Nice loop there. And also the other one that I haven't drawn yet is this vertex and this vertex's connection right there. So that edge, I can put it outside here. And now I've made it planar. Okay, let's make that neater. So how many faces does this graph have? Well, let's count. I've got 1, 2, 3, 4, and don't forget the outside, 5. So the number of faces for this one would be 5. Last one right here. Okay, this graph here is a bit trickier to do. Okay, but again, it can be made planar. Okay, so we need to redraw this graph. I'm going to start off by, actually, you'll notice how with most of these graphs, I always start off by doing your vertices. Okay, and then I will make the edges sort of last. Yes, that's it. Okay, now what I'm going to do is I can see that this graph is connected by a bridge. And if you don't know where the bridge is, it's right here. You'll notice that this graph was in a previous example that we did before. What I'm going to do, okay, is I can see that there's 2 graphs here. This is one. Okay, and the other graph is here, 2. What I'm going to do, okay, is I'm going to move this second graph underneath. Okay, and the reason why I want to do that is because I can see, okay, that this vertex is connected to that vertex, and I can still maintain the other connections. So the other graph here, actually I'll make these a different color. So that's this one right there. Okay, so these are the connections. Here we go. So I can see that this graph, the top half of it, they're all connected like this. Okay, and then the bottom half are connected like this. But I can see, okay, that this edge, this vertex is connected to that vertex. Okay, so how many faces does this graph have? Well, let's count them. I've got 1, 2, and the outside 3. So the number of faces here, faces would be 3. Okay, 3 faces. I know some of this can get a bit tricky, okay, but just understand that a few questions might ask you to make a graph planar, so you need to redraw it. Okay, some of you might be mistaken in thinking, if you don't redraw it, okay, that this graph, for example, might have 1, 2, 3, 4, 5, 6, 7 faces. Okay, but not correct, okay, because it's not planar. You can only have a face if your graph is planar. All right, let's move on. Last part here is Euler's theorem. If a graph is drawn such as that no edges intersect, meaning if a graph is drawn and it is made planar, okay, then this formula here should make sense. V plus F equals E plus 2. Okay, meaning that V plus F should be equal to whatever E plus 2 will be. There are other variants of this formula. I've seen it as V plus F minus E equals 2. Okay, exactly the same thing. Your textbooks might say this as well. So V plus F minus E equals 2. It might say this as well. It's exactly the same thing, okay? But basically, if this equation makes sense, or if a graph is made planar, then this equation should make sense. Okay, what do the letters mean? Well, V just means the number of vertices. F refers to the number of faces. E refers to the number of edges. Okay, so what we're going to do in these examples is we're going to prove that this formula works or is true from these questions. So example A, a planar graph has 5 vertices and 6 edges. Find its number of faces. So what this is useful for, okay, is for finding other variables. All right, these formulas, finding other variables. So let's work out A. A planar graph has 5 vertices and 6 edges. What I like to do here is I'm going to rewrite the formula. You can use either of these. They're both the same. I'm going to use this one though, okay, because this is the one I believe the textbook has. V plus F minus E equals 2. So for part A, a planar graph has 5 vertices, 6 edges. Find its faces. So it has 5 vertices. So that means it's going to be 5 for the V plus, we don't know how many faces there are, but there are 6 edges equals 2. Find F. So in this equation, okay, all you're doing is figuring out what F is. So we're going to be using inverse operations to find F, which is the unknown. I'll make this more obvious, make it blue so you guys are happy. All right, so let's put the like terms together. 5 minus 6 equals -1. You've got the plus F left over equals 2. Here I want to isolate the F, so this is a minus 1, sorry. Get rid of it. Here becomes a plus 1. Therefore, F, in this case, equals 3. So the number of faces equals 3. Sometimes what will happen with these questions is you'll be asked to, okay, you've got a graph, 5 vertices, 6 edges. It's got 3 faces. Now you have to draw this. Okay, so now you've got to draw this planar graph. All right, so let's do it. It's got 5 vertices and 6 edges, and it has to have 3 faces. So I'll start off by drawing my vertices. You've got 5 of them. 1, 2, 3, 4, 5. Okay, and then you'll be asked to draw. Now we need to draw the edges. Okay, so we have to have 6 edges in here. So it's got to have 3 faces. Okay, so you've got 1, 2, 3, 4, 5. Okay, and I can do this connection here because now this formula makes sense with this graph because you have how many faces? 1, 2, and remember the outside is also a face. So 1, 2, 3 faces. So that formula makes sense. Part B. Okay, let's do that one. B. Okay, use your formula again. This time I might use the formula that's given in this format to show you that it's exactly the same. So V plus F equals E plus 2. V plus F equals E plus 2. Alright, so part B says a planar graph has 4 vertices and 7 faces. Find its number of edges. Okay, 4 vertices, 7 faces. So you've got 4 of the vertices plus 7 f's equals e plus 2. Alright, so let's solve this. 4 plus 7 is 11 equals e plus 2. Okay, I want to isolate e, so make e by itself. I'm going to move that 2, bring it to the other side, it's a plus 2. Here it becomes minus 2. So 11 minus 2 is 9. And that tells me how many edges there are in this. So in this graph, you've got 9 edges. So let's prove this. So this graph should have 9 edges. It was 4 vertices and 7 faces. So I'm going to draw the graph for this to prove that this is true. So you've got 4 vertices. 1, 2, 3, 4. And it's got 7 faces. Okay, so this one's a little bit trickier. I might actually space this out a bit more. We're going to have 7 faces. So we're going to have to try and make 7 faces here. And we've got 9 edges to play with. Okay, so 1, 2, 3, 4. Let's see what have I got here. 5, 6, 7. So I've got so far 7 edges, and I need to have 9. Okay, but at the same time, adhering to the rules, I've got to have 7 faces in here. So far, I'm going to number my faces. Let's see. I've got 1 for the outside, 2, 3, 4, 5. Okay, so I've got to have 2 more edges, 2 more faces, sorry. And so I'm going to draw 2 more lines because I've got so far, how many edges have I got? 1, 2, 3, 4, 5, 6, 7, and I can have 9. And I need to have 7 faces, so let's go with 1 there, and I can put 1 here. So that makes sense now, because I've added another 2 lines, it makes it 9 edges, and I've added 2 more faces here, so 6 and 7. So there's my graph for this formula. Now, what I would encourage you to do is, if none of that made sense to you, rewatch this, okay, to understand what I did, or ask me some questions and I'll go through it with you, okay, and how to draw a how to get from doing this formula to proving it in a graph. I might do one more. If you want to watch me do that, I will do that here. Okay, so a planar graph has, let's see if I can make one up on the spot. Call this C. Okay, let's make this one up. A planar graph has, let's go with 6 faces, and actually let's make it a bit easier. 6 is a bit much. Let's go 4 faces, and let's go with trying to make this up on the spot, guys. 6 edges. Find its vertices. Number of vertices. I'm not sure if this example will make sense, but let's see how it goes. So planar graph has 4 faces, 6 edges. Find its number of vertices. So use the formula. V plus F, take away E. Oh, I used this one, equals 2. So I've got, I don't know how many V's there are, but okay, I know it's got 4 faces and 6 edges. It should equal 2. Okay, equals 2. Yes. So keep now we do the inverse iterations to figure this out. So put the like terms together. 4 minus 6 equals -2 equals 2. Okay, and then now this we move. It's a -2. Here it becomes +2. Therefore, V should equal 4. Okay, so now we have to draw this to make sense of it. So I can see it's got 4 faces, 6 edges, 4 vertices. So drawing my vertices first. 1, 2, 3, 4. I've got 6 edges to play with, and I need to make 4 faces. So let's make this work. So you can go 1, 2, 3, 4, 5. Let's see if I can make this work. This one's tricky. 5, where am I now? 1, 2, 3, 4. I've got 3. 1, 2, 3, 4, 5. Okay. Oh yeah, I think I can make this work. Okay, this works. So here in this graph, I've got 1, 2, 3, 4 faces. I've got 1, 2, 3, 4, 5, 6 edges and 4 vertices. Okay, this does take a bit of time getting used to, so I suggest that you just practice it using the exercises. Otherwise, again, ask me questions. I'm here for you guys. Otherwise, that's it for this chapter 9E, I think it was. So go 9D, sorry. So go ahead and start your exercises for 9D. Just a reminder, checklist is there. Tells you what questions to do. Thank you.